Hi, and welcome to solving linear inequalities in two variables. The important thing that we need to know about linear inequalities is describe the region of the coordinate plane has a boundary line. So previously, if we wanted to graph something like x is less than 1, we would draw a number line, put 0, 1, and 2, put an open circle, and then we'd shade to the left. Now if you do it on a coordinate plane, it looks something like this. X means that there is a vertical line. So we draw something like this with a dash, less than, and then we would shade everything on the other side. So you might be wondering why we did certain things. Like, why did we do a dash line? Well, when we graph a boundary line, the one thing that we want to know is that if we have a greater than or less than symbol, it's a dash line. If there's an equals to in it, we use a solid line. If it's greater than, we shade above. If it's less than, we shade below. Or we pick a test point. I'm going to show you how to pick a test point. If it makes the inequality true, then we shade to the side where the test point is located. If it makes it false, then we shade to the opposite side. Let me show you how to graph example number 1. First thing we want to do is we want to use, and remember that this is our y-intercept, and this is our slope. So start at -1, and go up from there, 3, and then right 1, 3, and then right 1, down 3, and left 1. And because it has this equals to symbol, it's going to be a solid line. Now, for the most part, since this is greater than, we want to shade above. But let's say we don't know what is above and what's below. How could we determine that? We could use something called a test point. In this case, I'm going to pick any point on here. I'm going to choose 0, 0, and I'm going to plug it into my equation and see if it's true. So 0 for y, greater than or equal to 3 times 0 minus 1. So 0 is greater than or equal to -1. That holds true, so I would shade on the side of the test point, as I did. Take a look at example number 2. Again, start at your y-intercept, so 1, and then in this case I'm going to go down 2 and right 1 because of the slope, or up 2 and left 1. Now, if you take a look at my sign, there's no solid line underneath, so I'm going to create a dashed line to show that there's no equality. And then it says shade above. Shade above is what I'm going to do. Now, take a look at this. If I use that same test point, 0, 0, which is now on this side, 0 is greater than -2 times 0 plus 1. Now yet 0 is greater than 1, which is not true. Therefore, wherever that test point is located, I would shade on the opposite side of the line, which I did. So it's a nice way to kind of check yourself if you want to. So what happens if you don't have an x in your equation? For example, y is less than or equal to 3. If this is the case, your slope is actually 0. So you would start at 3, you wouldn't go anywhere, and you draw a horizontal line. This horizontal line is solid because of the fact that there's an equals, and then less than. Well, we want everything that's going to be less than that, so we're going to go ahead and shade below. And again, if you need to, put in a test point. Is 0 less than 3? Or less than or equal to 3? It is. And 0 is right here. So we would shade on that side. A couple other scenarios that you might run into. Something like, oh, what if it's not in standard form? There's a couple ways that you can do this. Or I'm sorry, what if it's not in y-intercept form? Or slope-intercept form. There's a couple ways that you can do this. You can either find the x and y intercepts if you want to, or you can switch around the problem. I personally like to solve for y and switch around the problem. So 8y is greater than or equal to -6x plus 12 divide everything by 8. Y is greater than or equal to negative 3/4 x plus 3/2. And now I'm going to go ahead, I'm going to eyeball where about 3/2 is, so 1.5. And from that point, I'm going to go down 1, 2, 3, and then to the right 1, 2, 3, 4. Or I'm going to go up 1, 2, 3, and then to the left 1, 2, 3, 4. Solid line. And it's greater than, so I'm going to shade above. Again, if you need to, you can put that test point into the equation to see if it holds true. Just like a lot of these types of inequalities, you do have to make sure that you switch the sign whenever you divide by negative. So here I'm going to add 6y first, or 6x first, and then I'm going to divide everything by negative 4. When I divide, my sign has to flip. So from here, I'm going to start at negative 2. I'm going to go down 1, 2, 3, and then right 1, 2, or up 1, 2, 3, left 1, 2. I'm going to put a dashed line. And then in this case, I am looking at this symbol, this new symbol, so I'm going to shade below. Now, if you're like, wait, Mr. Stewart, I don't know if that's right. Okay, you can always use a test point. I like to use 0, 0. You just want to make sure that you use a test point that's not on a line. So I'm going to test. I'm going to plug it back into my original equation. Negative 4 times 0 minus 6 times 0 is greater than 8. 0 is greater than 8. That's not true, so I'd shade on the opposite side of that test point. All right, so how do we write a linear inequality from a graph? First thing that we want to look for is where our y-intercept is. So in this case, our y-intercept is at 0. And then we want to look to see if we can find our slope. So I'm going to pick 2 points. And notice that I go up 1 and right 1, or right 2. So my slope is 1/2. And then I want to also look to see exactly, is it a dashed line? And then where it's shaded at. So notice how this is shaded below, so be less than. So I'm going to have y is less than, no equality because it's just a dash, 1/2 x plus 0, or y is less than 1/2 x. I'm also going to write the linear equality to represent this. Again, I'm going to start here, my y-axis. In this case, I'm at negative 1. And then my slope is a horizontal line, so my slope is 0. That's a solid line, and it's shaded above, so it's greater than. So y is greater than or equal to 0x minus 1, or y is greater than or equal to negative 1. In certain situations, you'll have a horizontal or a vertical line. Always remember this. If it's a horizontal line, it'll be y is, and then your inequality, and then a number, no x value. There's another type, draw the graph here, that you'll see where it will be a vertical line. If it's a vertical line, I'll shade here just to kind of show you that this is an inequality. If this is a vertical line, what you want to look for is where it crosses the x-axis. In this case, it will be x is less than or equal to 2. 2 is where it crosses the x-axis. It's a vertical line, so it'll be x. And then since it's shaded less than and it's a solid line, it would be x is less than or equal to. Right? Those are some things, and that's basically all I have for you. Remember that you can always rewind this video and watch or pause it if you need a little bit of extra help. Okay?